So just before continuing with the whole building modeling example, I thought I would step back and just address the question, what if you didn't want to do it all in AutoCAD to start with and then import it into GSA? Is there another way to consider building the model? And that's what I'll just quickly cover here. So again, just a completely blank model. One way that you could do it is go into nodes. I've got a spreadsheet where I've defined a set of nodes. So these, again, are just kind of points in space. So again, you could type these in yourself. There's nothing kind of special about that. You can see the nodes there. We're in the analysis layer. If I rotate it, you can see there's one node down there. But let's switch to the design layer again. So Control-Alt-D. We're going to work in the design layer. So the sculpt toolbar, as I said, sculpting is the modification of the model and tweaking it and adjusting it, and that's the toolbar up here. So let's add an element. So that's this tool there, and by clicking that, you see you've got the element toolbars come up on the right hand side. You can set the property and the group and the type of element that you're about to create. So I want to create a generic 2D element, and everything else stays the same. If I wanted to, I could set it to be parabolic elements here. Again, it's not really that key at this stage. I then quite simply draw the slab or the slab panel. I didn't need to put it in the nodes, but obviously it needs to be between defined points. So it's put in the notional element mesh that you see there. In the same way as before, we can select that, and I can say maybe the element size is going to be really small, which is ridiculous, obviously. So let's do something a bit bigger. So yeah, so that gives us our slab element. Again, fairly straightforward. We could add in a void, so choose the void element. We've got that selected, and I can simply do something like that, and that puts the void in place. Interestingly, you can choose this tool to actually drag nodes. If I turn on the nodes, you can drag this node to there, and you can see it's actually altering the mesh or the potential mesh as I drag it around. So that's actually quite nice to see. So that's the 2D elements. We could do exactly the same for the columns. So again, choosing the add entities, add members tool here. We want our typical 1D element. And again, if we then just select the node there, and that puts in the element itself. If we switch to the analysis layer, as before, there's nothing at all there because we haven't created the model. If we go to model, coordination tools, create elements from members, all, and switch off the element numbering and switch off the node annotation. There you go. So that gives us the slab, the penetration, and the column. So you don't need to do it by AutoCAD. Obviously, it's at times much easier to actually import the geometry, but you could start from scratch by defining the nodes and then sort of sketching in the elements themselves. Again, it's completely up to you. So that was just an example of a way to create elements, to create maybe small sub-models, test models, without going to the effort of doing things in AutoCAD. Hopefully that's clear, and the principles that I'll be looking at in the rest of this tutorial can be applied to this. The AutoCAD import was simply an easy way to get the geometry into the analysis model. So continuing on, this is where we got to at the end of the last video. We've got our sub-model here, essentially a floor and the columns and the walls below it. So now we want to take this and make our multi-story structure. Again, I'm just making this up, but you can clearly see how it can apply to the design project that you're all undertaking. I'll also be adding in an inclined column as well. So again, to give you an idea of one way at least that could be done. So we want to copy this app several times. And I'm going to assume that the floor-to-floor height's exactly the same to make it easy for myself. So how high, or what's the floor-to-floor height? Now I could obviously go in and look at the columns. Obviously, if I was doing this for real, I would know my floor-to-floor height. But just as a way of showing you how to interrogate the model. So if we choose the node selection tool on the left-hand side, and I choose two nodes. So that node, if I hold down Shift, it allows me to do a multiple selection. So holding down Shift allows me to select multiple nodes. So I've selected those two nodes. If I right-click on the screen, I get the selection properties option. Again, the context is very good on the right-click menu within GSA. And you can see in the messages in the report window at the bottom, it gives me the X and Y coordinates of the vector essentially chain going between the two, and it's telling me that the distance between the bottom node and the top node is 3 meters. So we want to essentially copy the floor model app 3 meters at a time. So I'll start by turning off the grid lines and the grid. It's just a bit of a distraction for me. One thing I did notice is I've still got the pins, the constraints on the model. I'm going to turn those off or remove them for now. So if we do the same process that we did the first time, we've selected the pins, we come across to here and we say it's free. So there's no restraints placed on the model. So to copy it up, whether it's the whole model or a bit of it, the process is the same. We select what we want to copy. So I'm copying up the whole thing. Again, I'm working in the design layer, but the same tools, the same principles work in the analysis layer. You've got the pink options here, again, part of the Sculpt kind of suite of tools, but you've got the move and copy dialog by pressing this button, which gives me this. And it actually allows you to do a lot. It allows you to either move things, copy multiple times or move multiple times, that you can move them relative to different axes. You can specify your own axis. You can do translations, rotations, and reflections, as you can see there. So it gives you a lot of power to manipulate the model. Here, we're simply going to copy it up the floors. So I want to copy up. So I'm copying, I want to go up by Z by 3 meters each time. The dimensions that I'm working in, you can see here, that's based on the preferences I set at the start. You can choose if you want to copy up lists, loads, etc., etc. You can even choose what you want the increments to be. So for example, you could have the first floor being 100 hundreds in terms of the numbers, the second floor 200s, and so on. Again, it's up to you. I want to maybe, I don't know, let's say I wanted to copy this this app 7 times. Well, let's say 6 times, so I get 7 floors. You could either hit OK, which will perform the action, but I would recommend doing preview every time. And that way you can see what you're going to get without committing to actually altering the model. And that just is more of a time-saving thing. It can be a bit annoying to get the dimensions wrong or not quite have things as you expected happening, to have to come back and do it again. But here, this is what I want, so I'm going to click OK to essentially enforce that in the model itself. So that's now copied the floor plate app. If I zoom all, excuse me, if I zoom all, we can see we've got our building there. Again, just to make the point again, if I go to the analysis layer, there's nothing at all there, just the outline of what we've got in the design layer. If I shade the surfaces, so put on the section display, we can kind of see that's the design layer model. We've got the kind of penetrations in each floor. We've got the kind of doors in the core. So on the whole, it looks quite good. In reality, of course, there's going to be a slab over the top of the lift core. It's not going to be a void. I'm not going to do that just now. That's not the point. of this exercise. So that basically now is the model. So we've got the first, second, third, fourth, fifth, sixth, seventh floors. So I said I'm going to look at putting it in an inclined column. Now obviously I could have done this by importing the correct geometry, but there are other ways to tackle this. So let's take off the shading and look at how we can do that. So by way of example, I'm going to take the column on the corner here. And what I'm going to do is I'm going to say it's inclined from the first floor to the top. So I'm going to select the node that we have there. And let's move that just some arbitrary number. So you've got the axis X and Y and Z there. That shows obviously the kind of positive sense. So we want, again, I'm making this up, but say we want to go -3 in Y, and again, let's do the same in X, -3. And if I preview this, and again, this is where previewing can really help us to make sure that we've got what we want. And we don't. So I realized the mistake I made. I just paused the video there. So you see the red node there, that's been created based on the -3, -3 shift. The thing I forgot to do was change from copy to move. And although that looks like it's actually gone down, it's more the orientation of the view that's actually moved across the way. But again, that's the benefit of previewing. It shows, well, what's going to happen, whether you expect it or not. If I come back to the options, if I choose move this time, which is what I should have done to start with, and I choose preview, that has then pulled the slab to a new point, because it's obviously connected to that node. Now that again looks like it's gone down, but if we choose OK to come out of that and then slowly rotate the view, you can see that the column has actually moved. But again, it's not quite right, because although I chose -3 for Y, I should have chose +3 for X. So you see, I'm not going to edit this out because mistakes do happen. So you need to basically work with the software. Fortunately, we can just undo. So we go back to where we started at. So let me try that again. I select my node. There, so the pink box. I've changed the view a bit, so hopefully I can see it better this time. I move, which is what I should have done to start with. I want to pull this node back in the Y direction. So -3, say. I want to pull the node that way in the positive X direction, which is what I got wrong last time. So that should be 3. If I go preview, that's kind of what I'm expecting. So the top of that column is at this point there. So I'm happy with that. So let's now just zoom out a bit and look at the model itself. So obviously that's not the finished structure. What I want is to see an inclined column from there down to there. So to make the model easy to work with, and one of the things I do recommend is to use the volume tool. So you remember we can look at volumes of the model and exclude other bits. So if we go to the left-hand side, we choose volume, and really all I want to look at is this bay there. Again, because I've gone from bottom right to top left, anything that was in the volume was crossing, is still part of the picture. And that's not what I want, obviously. So go back to the volume tool. I've enclosed the corner I want, so that's all I'm actually seeing. So it's that N bay of the slab and the various columns. And this is the column that I want to incline. So how do I do that? Well, obviously I could put in the nodes work out the coordinates for the column coming down. But there maybe but there's maybe an easier way to do that using the tools within the software package itself. And what we can do is align a set of nodes. So the easiest way to explain that is by example. So I've got the node selection tool. I select the nodes, so you see the nodes are pink. I just turn it slightly. I want to also select the node at the top. So again, by holding Shift, I can add to the selection. So what I want to do is to align these nodes going up, like so. So what we do now, if we go to the Sculpt menu, so again, sculpting is modification, as the name suggests, you're sculpting the model. Then there's a whole series of options in here. I recommend you get, you might want to look over them to see what can help you in terms of creating your models. But if we go to node operations, and I want to straighten the line of nodes based on an even spacing. So what that's going to do is going to give me a linear relationship going up the building. So if I click straighten line spacing evenly, you can see it's now put the nodes in line. If I rotate the model slightly, you can see that the floors are still flat, which is what we'd expect. Using the various view tools, I can turn the model around. I can also use the arrow keys to rotate the model. But there you can see you've got your inclined column. And it's as straightforward as that. There are obviously lots of ways to do this, but that's a fairly easy way, a fairly straightforward way to get an inclined column. And of course, because the floor plate members, the 2D members, are attached to that node, essentially it's then altered the geometry of those as well, and also the mesh that will be created. So we don't need to worry about getting the mesh correct to start with. Once we've got our inclined column, the mesh is adjusted to suit that, and when we eventually go back and create our analysis model, that it'll be accounted for. So let's bring back the whole model. It's the whole building model. So that basically is what we have. Putting on the shading, we can kind of see the building itself. I believe if I turn on the animation tool, it just spins the model around. So you can see very quickly we've built our building model. And all that's left now to do is to analyze it. Well, to create the members, to create the elements, obviously, and then to analyze it. So let's stop that, bring it back to the center, turn off the shading. But again, you see it's been very quick to put in the inclined column. You could do exactly the same things with the columns on the other side to give you the inclined columns, for example, in the Design Studio exercise. So, as we did before, we go to Model, Coordination Tools, Create Elements from Members. I want the whole thing to be created. Control, Alt, and D switches between the layers. It's just taken a bit of time to create the model itself. And there you have it. So this is now our analysis model. But the thing I've forgotten to do is if I look at the elements I put on the nodes, I've still got 4 noded elements. That wasn't what I wanted. I want parabolic elements. So if I go back to Model, Coordination Tools, I want to basically kind of do it again, but with the correct element types. So slabs, you see that again, because it's part of the list, it's remembered it. I want to look at slabs, and I also want my walls, so type that in. I spelled it wrong. The list is only called wall. So that's all my 2D elements basically. If I choose the element selection tool, I can select everything. I can then simply go to the element dialog, the member properties on the right-hand side, where it's got linear elements there. I can just switch that to parabolic elements. And now if I were to select one of these, it's going to give me parabolic elements. So going back to the same process again, go to Model, Coordination Tools, create elements from members. Again, it'll take a few seconds to perform the conversion, and then hopefully when we switch back to the analysis layer, we should see parabolic elements for our slabs and also for the walls. So if we switch now back to the analysis layer, again, Control Alt and D, it looks very much the same as you'd expect. If we zoom in, if we turn on the nodes, you can see now there's a mid-side node to each of the elements. So again, we've got parabolic elements. And from your finite element classes, that's basically to do with obviously the shape functions and how the nodes displace and how then the stresses are interpolated on the elements themselves, integrated across the elements. So zooming out, if I turn off the nodes just because it becomes very cluttered. So that basically is our analysis model. We're now ready, or almost ready, to run the analysis. If I put back on my restraints though, so again, doing exactly the same thing as before, the node selection tool, I want to select the nodes at the base of the wall and the columns. You see there, I've selected actually the mid-side nodes as well by mistake. I want to get rid of that, so if I hold down Control to remove those from the selection. So remember, Shift adds to the selection, Control removes. So these are the nodes I want to essentially restrain. I'm going to say that they're all pinned. If I go back to my 3D view, you can see that the entire thing is now pinned at its base. So that's now all looking quite good, I think. There's my grid lines just for reference. So now, well, where do we go from here? We've got our analysis model. If I switch on the thickness, we've got thicknesses applied. The only thing that's missing from this, I think, is the applied loading. And that's what I'll do next. So I'm just going to update the lists. So you remember that I've got my members, I've got my slabs, like so. But if I look at the loading, so that's here, if I look at the 2D element loading, the face loads, because I've defined the lists based on members, there's nothing appearing here in the drop-down list, which isn't very convenient. Yes, I could type in the element numbers, but I don't want to do that. So if I go to general data where the lists are defined, I've got slab, wall, and columns. So I'm simply going to recreate them. I'll put an E at the end to show that it's the elements. So for the analysis layer, it's an element. As I said before, if you press equals, it copies what's above. And then I simply want to copy exactly the same thing. Because again, the elements, this grouping is exactly the same as I'll show you in a second. So if I close out of that, if I go to my select elements tool, if I select an element here, let's tell me that's group 1. Perhaps if I come out of that, if I select one of the wall elements, that's group 2. So it's essentially remembered or assigned the grouping to the element types, which is fantastic. because we can now see, well, that's members. If I switch to elements, the element list should, oops, the element list, if I go show lists, the element list is now there. And it's showing exactly the same thing, but it's operating on the elements. And the reason I did that, just to make the point again, is if I go back to loading, and I want to apply loads to my 2D elements, so the face loads, now the drop-down is populated with the names that I've given the lists of the elements. So I want to apply loads to the slabs. So the self-weight is already applied. We did that as a check before. I want to now apply a superimposed dead load. So that's load case 2. I'm not going to change anything. It's a uniform load. And let's say that that is -2. So a fairly standard SDL. Also to the slab, I want to apply a live load. So again, we defined the self-weight, the SDL, and the live load in the last video, essentially by going to the load specification here and typing in these names. Exactly the same. I'm going to say that, let's say the imposed load is 1.5 kPa. So again, fairly straightforward stuff. So if I now look only at my slabs, again using the elements and the list to view the slabs, I should, if I turn on the load diagrams, so that's at the right hand side, the arrow I'm pointing at now, nothing happens because in cases that you see here at the kind of top left of the screen, it says none. But if I look at self-weight, and it's taking a bit of time just because that's the number of elements, you can see all the applied loading. If I look at the SDL, that changes, and the live load changes again. That doesn't really tell you that much. You can use the annotation tool, as we did before, on the left-hand side that I'm looking at here, to select an element, and that's showing me that the live load is applied as 1.5 kPa. That's all a bit of a mess. I'm certainly looking at 2D elements. So as I did before, I would typically go to the contouring options, look at loading, look at 2D element loading, look at face pressures, so just going through the menus. And if I select loads based on actual values and click OK, again, it takes a bit of time, but it's 1.5 is the actual value. If I use a plus and minus to cycle through the load cases, the SDL is 2. It hasn't changed the colors because it's scaling the contouring. I haven't set it as a constant. If I go back to the self-weight, it's 6.472, which is based on the thickness of the slab and the weight of the material itself. So that's showing me, and again, it's important to check that you have applied the loads correctly. And this is one way to do that. So let's get rid of that. And I'll turn off the grid as well. I will look to see the whole structure. So now we're almost there. We've applied the individual loads or individual load cases, but typically that's not all we want. We typically want to combine the loads maybe with load factors. So the last step is then to come down to tasks and cases. So we've applied the loading here. We've specified the loading names to start with. We went into face loads to apply the load to the face of the slab. Although I'm applying it to the slab, the same dialog is broadly there for beams as well. If you've got a beam list, you can apply point loads or area loads or line loads to a beam as well. It's the same principle. Again, you should be able to figure that out by playing around with the software. So if we just close that up. So the final step is for tasks and cases. Now, we don't need to worry about analysis tasks unless we're doing a bit more advanced analysis, so maybe staged analysis, maybe dynamics. or things where you've got nonlinear effects. So I'm not going to look at analysis tasks just now. You can find that in the manual, and also there's various videos on the Oasis website. I'm going to go straight to combination cases. So we've defined our load cases before. We want to now combine them. So we could type in or press the wizard button to create a combination case. Typically, I don't use that, but if I said I want my SLS case, for example, so my description. So you remember, if I maybe go back to the load cases here, excuse me. Now, in the same way that you can move views around by pressing Control, by holding Control and pressing the number pad, you can do exactly the same with tables as well. So if I hold Control and press 8, that puts the combination cases to the top. Control and 2 has placed that there. So these are the load cases. So what I want to do, so apologies, just pausing the video for a second. So what I want to do is then define what forms that combination. So although I'm calling these the self-weight, the SDL, and the live load load cases, in reality they're analysis cases. And when combining them, that's shortened to A. So A1 is the self-weight case, so the case 1, plus A2 is the superimposed dead load case, plus A3 is the live load. If I hit return, it tells me cases are missing because I haven't actually analyzed anything yet. So then maybe I also want an ultimate load case, so ULS. So we know that the dead load factor typically is 1.35, A1 plus A2, because A1 self-weight, A2 is a superimposed dead load, plus 1.5 for the live load factor is A3. So A3 is the live load. So that gives me my ultimate, my serviceability cases. And you could do a whole range of these. You can envelope if you've got different cases that you want to find the worst of. And again, all of this is in the GSA manual. But this is the kind of key or the fundamental way of creating a case or a set of load combinations. So just to recap, these are the load cases or analysis cases. The case there is 1, 2, 3, corresponding to self-weight, superimposed dead load, and live load. Effectively, there are analysis cases, hence the A prefix to each of the numbers here. 1, 2, and 3 correspond to 1, 2, and 3 there. The load factors that are applied, it's just simple algebra in terms of the ordering and in terms of brackets. And again, there are various help sections in the GSA manual to explain the syntax as well. So that's really everything I think we need to do. I can close these. Again, I'll need to save my model. I'm forgetting to do that. And now in the cases tab you see there, you've got the self-weight, the SDL, you've got the live load, but also now I've got my combination cases, C1 and C2, the SLS and ULS cases. Of course, I haven't actually analyzed the model yet, so there's going to be nothing at all reported. So to analyze, you simply hit the first sigma button. And if we do that, it shouldn't take very long. Yes, there's a lot of elements, but it's still a fairly straightforward model. So I'll just pause the video and wait for that to finish. So that's the analysis complete. For reasons I'm not completely clear on which I need to look into, I actually had to go back and apply torsional restraints at the bases of the pin columns, and I'll need to look into that. It was just required to get it to run as part of the model's overall stability. It doesn't seem to affect the results. It's just well, an interesting part of the analysis. If I find a reason for that, I'll of course update this video. So you see there's X and Y, Z, and the ZZ, so the rotational restraint, again to give the model the required stability. So that's it basically. We've now applied the loads, we've analysed our model. If I look at this in the full screen view, if we just by way of example, we can turn on the bending moments. That's obviously the bending moment in YY. You can come to the diagram options here to look. If we go to beam, spring, force, and moments, we can look at the torsion, the bending in each direction, as well as the axial and shear forces. If we look at the axial force diagram, so these are the diagramming options there, the color contouring options below them. If we look at the axial force, as we'd expect, you get the increased axial force as you come down the columns. I'm not going to go into this in detail. Again, you can look at the outputs yourselves. You can look at the reactions, obviously. If you click the annotation button and go over what you're interested in, it should tell you what the values are. Again, you can alter the decimal places at the top. You can change between the analysis cases, obviously, to see what the difference is in terms of the results for a particular case or component of that case. Come back to the full screen. And as I said before, you've got the option here in the top left for the output view. You can actually then choose to look at either displacements or forces. So I'm going to choose maybe the forces, and I want my columns. Equally, if there's one column I wanted, so for example, if you wanted to isolate the results from a given column, you could type that column in there, a column number or name, and simply that's giving me all the forces for each of the combination cases that's come out of the analysis. If I hit the wizard button, again, I can use the options here to refine how much information's been output in the table itself. Maybe I don't want, as is shown here, the results at 25, 50% and 75% of the distances along the elements themselves. But again, you can look at that to decide how you want to output the results. So really, I think that's it. We've built our model with an inclined column. We've got our slabs. We've got our penetration going through the slab itself. So again, all fairly straightforward, very quick to construct this analysis model, apply the loading, and really, do you actually need any more in terms of the design project? And of course, although I've actually built, obviously, a part of the structure, multi-story structure, you might want to say, well, yes, well, this is good because it shows me how to use GSA, but do I really need to do this? So I've shown you how you can build a whole building model with an inclined column, but do you actually need to do that? Again, it really is up to you to find the most efficient way to get the results you need to design your structure for the design project. And whether you need to go into this level of detail, again, is debatable. And perhaps you might only use something like this as a load takedown a tool, for example. Maybe you just want to look at the overall reactions. I don't know. Again, it's really up to you. So the final thing I'll look at with this particular model is if I look at it on a side view, and I'm going to select maybe this zone there. So basically what I've got there is turn this back on, is the floor plate and the columns and walls on either side. And it's 1, 2, 3, it's the fourth floor. So I'm going to right click and I'm going to save selection as list, and I'll call that fourth floor. So if we go to our list table of elements and go to the fourth floor, we can isolate or just have an easy way of viewing this particular floor. But the reason I'm doing this is that one of the other features in GSA is that we can actually extract lists into their own models. So for example, if you wanted to extract each of the floors into their own submodels, you could do that. If you wanted to extract only the cores and the columns into their own submodel, perhaps for stability, you could also do that. So I'll save again. So remembering that this is obviously the entire model, and I want to extract the fourth floor, how do I do that? So go to the modeling tools, and if I can find it, it's again in the coordination tools options, which is the extract submodel option. Sorry for the delay. So if we click on that, so what's the submodel we want to extract? Well, you can see there it's basically defined or giving you the options based on the lists that you've defined. So I want to extract the fourth floor. We haven't defined any analysis tasks, so we can ignore that. We can put in details here, so maybe fourth floor, say. Depending on what you're doing, you can either extract the components as a submodel, so essentially you're going to apply constraints to it yourself, or you can take into account the loading applied by the structure itself. Again, you can look at this yourself and test it out. I'm just going to go for the first option, so that essentially to create a standard subframe model that's independent of anything else which is happening. So that's global, as you see there. There isn't anything, I think, here that needs to be checked, so that's fine. If I click OK, it's thinking about it, and what it's going to do is extract that floor, all the loading that's applied to it, and essentially when it finishes doing that, it's going to come up with the option to save that as its own model. So I'll pause the video and come back when that happens. So it's processed it. It's asking me to give a name for my submodel. So let's say fourth floor, and click Save. So that's now saved a separate file. That shouldn't happen because it's just trying to open up GSA again, and just because I don't have enough licenses for that. But that's the model we had. If I close that, if I open up the model I just created, so that's the model. So 002-2 and the fourth floor, and you can see there that's the analysis model. If I click all, you see there's nothing else there, although it has remembered the analysis cases. So it's not analyzed, obviously, so maybe I want to put in my restraints. So I'll say it's apologies. So when it's extracted it, by virtue of me telling it it's a submodel, it's already put in the restraints. I don't like having the tops fixed. Essentially, that means it's hung from above. So if I select those, I want to remove that, again pressing Control to do that, and I want to take out the Z restraint, so essentially allowing the whole thing to settle as required. If I save that, then everything's there. So what this allows me to do is to focus on the floor in question. I take off the annotation. So that's essentially one of the floors, and I might argue that, well, if you design this floor in terms of the floor slab, If you've chosen the worst floor, well, that's really all you need to do. There's no point in designing all of the floors. So if we run the analysis on this, and we get lots of error messages. So as I mentioned or copied on the previous slide, I think the issue had been I chose the wrong options when I extracted the model itself. So hopefully this time it'll work. So if we go to the fourth floor, I put back in the title. I don't want to open the model as soon as it is extracted. That's why we got the error message before about the licensing. The option I made the mistake of choosing was global. I don't want the boundary conditions and settlements to be copied over. I just want a local submodel to be created. So hopefully now if we click OK, it'll export the model. I can then save that, and then we can see what happens when we reanalyze it. Hopefully it'll work this time. So I've opened up the subframe model as before. And as before, it's got fixed nodes top and bottom. And if I take, again, a selection there, get rid of that. And I want to remove the Z restraint. So again, it's not hung from the top. Now I admit I'd actually run this already, and it still gave me an error message, and it took me some time to really understand why. And I think perhaps there's a bug in GSA, because even though we've said we don't want to extract the settlements, you can see here on the left hand side in settlements a whole range of these have been extracted with the model itself. Again, that's wrong. That's not the option that we chose, and that was the issue that was giving me all those error messages. So to essentially get around that, if I right click in settlements and choose delete, so there's no applied settlements being imposed on this model, and that's not what we want. It's not what should have happened. So I think that's a bug which I'll feed back to the developers. So now everything should be fine. So hopefully if we run the analysis, it should all work out. And there you go. So that's analyzed successfully. The warning relates to the settlements that I removed. I think there's analysis tasks having been carried over. Again, that's not there isn't really anything to worry about there. Again, obviously you need to check the models that you do. But that then gives us the submodel of a floor. It allows us to look at, I don't know, moments, again for say SLS, ULS, and all sorts of other issues related to the behavior of the floor. And I'll follow up with a separate tutorial, maybe looking at this floor plate and how I would maybe go about designing it. I think I would just end here by saying, well, as you've seen, although most of this went relatively smoothly, there were a few issues, and even though I've been using GSA for a long time, still these things do come up. So don't feel bad if it takes you a bit of time to get used to the software. And again, often stepping back and just thinking about what's going on and doing the basic checks on whether you've put in the right restraints, whether you've defined the material properties correctly, and also, as you just saw, whether the loading is correct, especially if you've extracted the analysis. Has anything odd been carried over? Again, it's all the kind of checks that you need to do both in your design project, but also in practice. It's what we would do in the design office as well. So I hope that's been useful. And in the next video, I'll look at this floor plate, maybe looking at the connectivity between the columns and the slab, as well as more on the interpretation of the results that we see here. So thank you for your time.